I'm 𝗤𝗲𝗄. I'm a PhD student from OIST. I'm so happy that I got the chance to be actually in contact with your organization to try to be helpful to teach some intermediate level of Python for people interested in Afghanistan. I prepared. Do you hear my actually sound clearly? Okay. Let me quickly start my introduction. And I need to tell you that it's my first time, so please accept my apology in advance if it's not really looking professional. I'm here just to learn also how to actually share my knowledge about Python. I'm 𝗤𝗲𝗄. I'm originally from Tehran, Iran. Maybe I can speak in Persian. Salam vaqtetum bekhair. I'm PhD student at OIST, and I started my PhD almost 5 years ago. I'm about to finish my PhD here, and I am doing an experimental research regarding light-matter interaction for quantum technologies, and under supervision of Professor 𝗖𝘂𝗿𝗶𝗁𝗍𝗔𝗍𝗍, because actually she introduced us to this activity. I don't know if you can clearly see my screen. I try to. Sorry, give me a second. Okay, yes, there you go. As you know that we are at OIST in Okinawa. It's such a beautiful campus with focus on subdisciplinary research. For example, when we try to combine different fields of research together and try to have like some world-class actually research. Just to give you some idea how far from each other, Afghanistan, Japan, Okinawa specifically, and then in Onnasan is the name of the village that OIST is actually built there. We are actually staying here in a very beautiful campus, as I showed you. It's very close to beach, and we are really surrounded by a beautiful, fascinating nature. Briefly, I need to explain, this is the unit that actually I work with, 𝗖𝘂𝗿𝗍𝗍𝗍𝗍. It was actually her effort that linked us with you, and I personally feel so happy and glad to get to be part of this plan. I guess I am pretty done with my introduction. Let me know if there is a question or if you want to know more about OIST or what any other questions you can think. I guess I already shared my Google Drive folder with 𝗖𝗍𝗍𝗍𝗍, and I'm happy to share it again. I'm not so familiar with Google Meet because we always have our online meetings with Zoom. So if there are some problems, please let me know. I don't see any problem for now. So we continue and we decide how to actually proceed with this step. I don't know, Javid, if I need to pause and other people need to introduce themselves, or I just need to continue.
I think it's depend to you. If you want to have a short introduction from the students, it's also fine. If you think that you want to start the class, it is also okay. You have full right. What you want, you can.
Yeah, thanks. I guess as we are 20 2023. It might be a bit time consuming, but I always like or welcome introductions because I guess it makes our interaction more realistic. At least we get to know each other by few sentences. But I guess as we are pretty a lot, maybe we should skip. But I'm really happy. Please interrupt me if there are some questions or if you want to actually bring up some topics or you want to talk about anything. I guess maybe for now we just skip, but let's be in contact afterward. Let me just quickly go to my next slide. Sorry. Sorry, a second. Let me just... Okay, I guess I need to stop presenting. Give me a second, I'm sorry. Okay, thanks, you can see. As me and German, my friend, who is also a PhD student at OIST, decided we want to present an intermediate level of Pythons to you. In first session, I quickly, as I told you, this is my also first experience, so I need to get some feedback. So please provide me with some feedbacks. I quickly talk about Google Colab, the platform that we are using for this course. And then in this session, I will try to talk about basics of data processing and analysis in Python. Today, in a specific, I just focus on NumPy library. But in next session, as you can see, I will focus on Panda, which is the actually latest I would say platform that you could have access in Python, and how we can get some use out of it for data analysis. And the third session, I will talk about data visualization with Matplotlib and Seaborn. I guess for now, if I want to just be focusing for this session, I will talk about roughly that what we are going to focus on this course, some basic definitions of data processing and analysis, some important functions like arrange, range, creating NumPy, basic operations on your data set, indexing, slicing, navigation, reshaping, flattening, Boolean indexing, and NP-where, which is actually good to have access to your data, and some sort of broadcasting function just to be able to get you, be having access to our data. Let me just share my other. Let me just stop sharing. Yes. Okay. Yes, you're all familiar with Google Colab, am I right? Is there anyone that is not familiar with Google Colab? Okay, I guess then it's nice. That means there is no problem. As you can know, I just go through the basics that I guess there are few people that are not very familiar, so just please let me quickly go through the details of Google Colab and why we are using Google Colab instead of other opportunities to have access to Python. First of all, how to access Google Colab. We just need to go to the website colab.research.google.com just to create actually new Google Colab environment for us, which is needing to be connected to our Google Drives. I mean, if we have Gmail accounts, we have access to our Google accounts, and then through Google accounts, we can activate our actually access to Google Colab. But why we are interested in Google Colab? Because first of all, it's free. It's like all possibility of having access to Python, and it's an online Jupyter notebook, and you don't need to actually install anything, and it is not actually run on your personal PC, but it's run on Google servers. So there is no need to have some installation in your PC. So it gives us such an easy access to actually Python. So that's really the reason that people these days, specifically for people who are working with machine learning, AIs, Google Colab has gained really popularity because of having easy access, online access without any need to install anything in your system, which makes it much easier. But just given some idea, Google servers offer you 3 different actually level of access to their servers. First is CPU. It's just for like general use, and it can run easily, not really heavy heavy programs, I'm sorry. But if you, for example, doing some machine learning or some other codes that needs really like a lot of resources, you can switch to either GPU or TPU. I can show you here, for example, if you see, go here and on the runtime tab, there is like an option, change runtime type. As you can see, for example, it's set into CPU, which is the most basic and the smallest level of access to Google servers, and GPU and TPU. But in case if you even need more resources to run your program, you can actually apply for the paid version of Google Colab. So they will provide you higher capacity in their servers. But in general, for normal use or general access to Google Colab, these 3 available free options are really sufficient, and they can provide you with a good level of access to Google servers. Yes, for example, as the most basic aspect of this Google Colab, as you can see, when I actually come close or hover close to the 2 different sections, 2 types of cell can be chosen. First, code, just to insert your Python code, and then the text cells for explanation using in Markdown. If you need to add some explanation to your code, or if you need to, for example, comment something outside your code, so you always have this access. And you will see in the continuation that I have been using both of them very frequently. This is like a very basic introduction of Google Colab. For basic and general use, I guess it's sufficient. I guess I see someone has a question, please.
Excuse me, the image is very small in the center. Can you please wait this your image is okay, but this your presentation is very small.
I see, I see. Let me, just, I don't know how to. Okay, let me, I don't know, what is this short key for zoom in? Let me quickly search. Just pin it. Give me a second, sir. Control. Yeah, control. Is it better?
Yeah, that's better. Thank you.
No worries. I can even go a little further. Okay. I guess we lose a little bit of like. So, okay, this was just like a very short introduction for what is exactly Google Collab page. It's a free. There is one more question. Am I right? Okay. I guess it's. Sorry. Okay, we just talked about the basics in Google Colab, and then in order to have access to all possible libraries that are useful in Python, we have different approaches in Google Colab. Some of them are already installed and available in Google Colab. It's like, as you can see here, there is like, we simply just use the command import the name of the library that we need, and we name it in a way that we want to actually work with. And then, for example, if I just want to, just give me a second to a little zoom out. If I double click in this actually row, you see this is like a text cell style. But here, this is like a code cell format. So for the code cell formats, you see that you have like a run option. So for example, just as an example to show you that already available Python libraries in Google Colab can be actually called and used in such a way. You just use a command import. For example, in this case, I just imported a TensorFlow library. Import TensorFlow as TF, and it gives me the version. If I run, you see that it's successfully imported, and it gives me the version of this library that I'm using. But Google Colab doesn't necessarily have all available Python libraries. But there is another way that we can actually import other Python libraries that are not already installed inside the Google Colab using actually this command. I forgot the explanation, I'm sorry. Pip install, for example, Jim, I want to insert this one, and then you see that if I push the run, it's I mean, the requirement is satisfied, and it shows that because I already ran this code. So you can see that I could, using this actually line, I could add one of not available Python libraries to Google Colab. If I just want to, so these are like how to deal with Python libraries in Google Colab. So as you can see, we have access in such a way. Some other basics in Google Colab, for example, if you want to open one of the files that you already have or you have already put in your actually Google Drive, you just go to File, and then, for example, open notebook, and you see there are different options. For example, if you have recently opened from your Google Drive, you can open your Python or your actually files. If you have some like space in GitHub, you can actually have access easily from here, or you can even upload. I mean, these are just some basics just to review. One important item that we should keep in mind since the beginning is how we deal with shared files. I strongly recommend you, if you use, for example, one shared Google Colab file, please don't simply save. Because that means if I already shared something with you and you made some changes, then, and if you just simply save, you are changing actually my shared file. To avoid this problem, because it can really make our actually shared files very messy and problematic, we just need to, for example, if you work with a shared file that I shared or later Gammon which will share with you, just go to File, and say we choose the option Save a Copy in Drive. Then it will create a copy of this file in your own Google Drive account. So that is safe, and then you simply rename and having access to what you need. And if, for example, working with, this is very important. It sounds simple, but I guess if we want to continue this process, we need to be careful all not to make any changes with shared files. Then, for example, if in the end of your actually coding, you want to just download your code, you just go again, download. You go to File and choose the option Download. You have two options: download IPYNB or PY. I mean, the first one is highly recommended because it's more popular and more modular. I mean, you have better access into editing and actually controlling your saved or downloaded file. Okay, this is actually pretty important. Maybe I should have mentioned it a bit earlier. Mounting a Google Drive to your actually Google Colab. You know, using this line from Google Colab import drive, you go to your Google Colab library and import the drive which refers to Google Drive. And adding this line, you actually kind of mount or connect your Google Drive with your Google Colab actually file. That it's as if you inside your Google Colab, you have access to your personal Google Drive using these two lines. You see, for me it says drive already mounted because I've been using this folder, so it's already mounted and it's already actually set in my system. But this is actually important. If you don't have this, I've already shared, I guess, my Google Drive, so you can just copy and paste this part in your Google Colab, or I mean, you can just run it and then make a connection between your Google Drive and Google Colab. These are actually some, again, some simple, actually, options that we have in Google Colab. For example, if you need to add an image, again, for example, I also, for example, I from IPython display library, I import to actually function image and also display. Using them in series, I, for example, give my address to the image that I want to insert and then display, and have chosen the size of this size. For example, I've chosen 700 for the width. If I, for example, run this line, you will see, for example, it's just a FemsTech page picture. You can import your images into your Google Colab file. These are just some basics. Then we already imported necessary Python libraries, and we have access. We understood how we make a connection or mount or Google Drive and Google Colab. And this was just like a simple idea of how to import images if you need to add some, for example, image to your code or whatever that is necessary at that point. Just really, let's get to know about some basics. Based on my experience, they were all useful in using Python later on. These are some just details that, I'm sorry, it's just my also first time teaching Python, so I don't know if the pace is okay or not, but I decided based on my own understanding of Python. For example, this is one, like some example that I provided for you. For example, if you in your code cell, if you, for example, add a number x equal to 25, let me just control X. If I run this, you see, for example, x is equal to 25, and I ask to show x. Y is 34, and I ask to show or display y. But when I actually hit this actually running button, you see that it only shows the last parameter that I have defined. To avoid this problem, instead of simply typing x to display x, we use the the function print. And then, or you can leave it this one, but if you want to be like more organized in terms of typing, for example, you do this, and then you can see that both are printed. I mean, these are just some basics that I have already made some mistake. I just wanted to let you know in advance if these are some get to know about what we can do here. But this is another example. If you choose, for example, one text set. Here, if I double click, you can see that I have, for example, access to the original data that I have typed. One hashtag gives you the right big size. If you want to just tidy up your writing in your coding, and then double gives you like a subsection size, and then triple hashtag gives you like a subsection, just to have a better organization of your writing style in your Google Colab. And I found them pretty useful. To like a code cell, using this command, it gives you the current directory that you are already working in. For example, if I run this cell, you can see that I'm in the content directory. But if you are curious what other things that exist in your directory, you just use this one and you see I have like inside this directory, I have like drive and sample data. Again, if you are curious what you have in your sample data, you just type this command and then it gives you all possible actually files. For example, for me is this available. I guess we are also, it's resembling of here, drive and sample data, as you can see. But you can have access using this command. Okay. Another, I guess, maybe required commands that it's good to know in advance when you are using the collabs, Google Colabs, is actually like a pip list to see the list of installed library in your collab. Because in case if you don't know which libraries are already available in Google Colab, so you can use this command just to see. For example, it gives you a very long list about available libraries in Python. In Google Colab. Here output. And then, for example, if you are not sure which version of the library that you are using in your Google Colab, this command is very useful. You just use pip install, upgrade, and then the name, I don't know, dash, I would say, upgrade. I'm sorry, I'm not a computer scientist. I am not very familiar with the lexical resources required for actually Python. And then upgrade, for example, NumPy. In this case, I ask to upgrade to the latest version my NumPy library. But you can put your desired library to upgrade your Google Colab with the latest available version of this library. Yes, I'm sorry, I had a typo here. Okay. I guess it's already, you see, successfully uninstalled the previous version and successfully installed the latest version. So, you can just change NumPy and put whatever library you need to get the latest version. This is, we just already talked about. Okay, let's start our actually Python course with an introduction about what Python is in terms of data processing and analysis, and then in the continuation I will just explain important functions and options that we have to do or start our data processing and analysis in Python. As you can see here, there are mainly 10 actually I would say library for data analysis and processing in Python. The most famous and most basic one is NumPy, which does only numerical computing, which we will focus in this session more. The most sophisticated and the latest version that is very popular nowadays in Python is Pandas. which does a very good job in data analysis, data manipulation, dealing with really data in table version. It's like a very powerful tool to deal with very structured data sets or very complicated structures in data sets. And then Matplotlib, which is the most famous library for creating plots out of data analysis and processing. I briefly also talk about Seaborn. It's another way of creating plots, but in a very more like detailed and more eye-appealing way. So, can you please provide the code editor you are using? Code editor. Let me answer this question later. Let me just finish. Let me just write them. Oh, yes. I guess this is actually Google Colab that I'm using. Sorry, I was a bit confused with this question. Mm-hmm. Because we are using Google Colab. Whatever I have written here is on Google Colab, which is like a free online notebook. I can explain it again, which is not run on your PC, but on Google servers. It's just like a collaboration between Google and Python, just to have much easier access to Python. Okay. Back to our, there are other packages or libraries that are being used for data processing and analysis, but I don't explain them to you. But like, for example, as just to get to know about the names of these in case if you have some need, SciPy, scikit-learn, stats models, OpenPAXWall, Plotly, and DASP. For this course, which I have only 3 sessions, I try to cover these 3. But as I said, this session, I was just a bit careful to not, for example, go too much details. But in order to be on the same page or found our equilibrium, please do let me know what you exactly need, what you want to do, which, for example, functions that you, for example, want to get to know. So maybe I can change my actually contents based on what you really need. But these are just some basics that I personally use, so I hope it's useful for you. But please provide me with some feedbacks that then we can actually be more on the same page and make this course more useful for you. But as I said, what we really focus on in this course is NumPy, and as I explained you, it's really useful just for numerical computing. When you want to deal with fast array operations, linear algebra, and numerical functions. For more sophisticated way of data analysis, and manipulation, as I said, pandas really recommended. Then you can, for example, deal with huge databases in Excel and other, for example, table-shaped data sets. It's been used for data cleaning, data grouping, data filtering, which we will focus on next session better. And then for creating plots, we just plot line graphs, bar charts, scatter plots, and histograms using matplotlib. But for more like higher level plot, statistical data visualization and pandas based data frames, I mean, professionals really recommend Seaborn because they give you very like, it can give you more like attractive or eye appealing graphs. Then you can play with the details. Just to wrap up the basics about data analysis and processing in Python. As I said, for example, as you can see in this chart, NumPy is the cornerstone of the Python, cornerstone library in Python for data analysis. And after that, SciPy is really sitting on top of NumPy with some additional features like, for example, miniaturization, regression, Fourier transform, and so on and so forth. And then matplotlib is just for like covering the visualization of whatever you get from NumPy and SciPy. And on top of all of these is the pandas, which is actually referring to data, panel data. And based on the reference that I was preparing, is the youngest child of the family. It's on top of all other modules. And it's really dealing the best with table-like data sets. And it's really good for data manipulation and analysis. As I told you, we start with this NumPy. Okay. Let's just dig into some details about what we mean by data arrays or data objects. If I want to really quickly talk about type of data that we can have, NumPy has a very powerful aspect which can provide data as NumPy arrays. What are the benefits of NumPy arrays? NumPy arrays are good for a smaller memory consumption. They require less amount of memory. So it's really good to get used to NumPy array because you actually deal with smaller required memory. So it makes your coding more optimal. And in terms of runtime, it has it's better, and it actually deals with. It requires less time to actually run your code. NumPy, as I said, the powerful key of NumPy is just using a NumPy array, set of arrays, which makes this to happen easier. Let me just zoom in if I can. Okay, let's go and start with basics in NumPy. For example, if you want to create a NumPy array, you just use the command np because we imported our, let me just import NumPy as np. So just to create your NumPy arrays, which also support decimal numbers, and there is no need to change it to like list. I will explain you afterward. You just use the command np, which is referring to our numpy arrange and range, which is for example 1, 2, 3. And if I ask to print the A, you can see it creates number from 1 and it finishes before 10. It's 1, 2, 3, 4, 5, 6, 7, 8, 9. As I told you, it can support non-integer values also. For example, same command, but I say 10.4. So instead, it starts from actually 0. And it goes all the way to the integer value before 10 point. Sorry, if possible, could you work with Visual Studio Code? I have never, I don't use it to be honest, so maybe German is actually, he can be more helpful in these aspects with you guys. I just use Google Colab and that's it. So, sorry. Okay, then this is the most basic way of defining your arrays in NumPy or in Python. But there is another actually function that can be sometimes confused with the previous one, which is range, which is only an iterator, and it has a very different actually nature with a range. So, for example, if I, for example, instead of saying a range, I say range from 1 to 10. You see, for example, if I just print X, it just prints the same line as before. But then here you need to define a list just to make them readable. This, as I told you, for this one, it's automatically print out the required numbers, but for this one you need to make write such a command just to make them printable. I mean, these are just, they can be easily confused. I just thought maybe it's good to talk about it once in the beginning and then to avoid any confusion or mistakes. So as I said, this one makes you NumPy arrays, but this one is just like creating iterators for you. Let me see, 1, 2, 3, 4. I mean, it's a bit different. Let's, for example, practice like creating NumPy arrays. For example, for a 1D sort of array, we just say, for example, my NP array is sorry, for example, this is just like give you a range, and this is just give you your desired array that you would like to introduce or import in your Python code. For example, I want to create a 1D array which includes 3 numbers, 1, 2, 3, and I call the whole array as A. Using the command print, I will ask to print this array for me. Using a.shape, I get the shape of my array. Using, for example, a is referring to the name of the array, which is defined here. A d type, it gives you the type of array, and n beam gives the dimension of your array. Here for like a 2D array, for example, I have like one array of 2 rows, 3 columns. For example, for first row, 1, 2, 3. For the second, 4, 5, 6. And then again, I ask to print the array for me, give me the shape, give me the type, and then give me the dimension. Let me just clear output. And then run this cell code to see how it works. For example, you see A is 1, 2, 3. Shape means I have 3 columns and 1 row. I have my type is integer 64, and dimension is only 1 because it's like a 1D array. But for B, I have, for example, 2 rows and 3 columns, and type is again integer 64, and dimension is 2 because it's like a 2 by 2 array. But you can see that we have like an integer 64, but you may not want to stay in this type, and you, for example, define the term. I mean, a very, what you need out of your. For example, what you want to define as a type for your array. For example, we go back to the example of A, 1, 2, 3, but instead of integer 64, which is a default type for your arrays in your Python, you change them to float 32. So you define your own actually. It makes it like a floating instead of integer. And then if I run this one, you see it's not integer anymore, 1, 2, 3, and it's float 32 type. Or for example, I guess we can change it to 64 as well. Yes, it shows the accuracy of decimal numbers after decimal point. This is it. And this is just a way that you can define your arrays in here. I'm sorry, the time for this class was 1 hour. I'm sorry, I forgot to check. Oh, okay. It's from 6:30 to 7:30. We have only 5 minutes left. I have already shared the link of this file with Javi, but let me know if I can say, maybe I can, let me just quickly, let me, enable this quickly. I put the link here, then you would have access to my, please have a look into the chat box. I already shared my the link of my Google Drive, so you have access to my Google Colab notebooks, so you can continue after changing this. Can you please send it through email since it's not working for? Yes, sure. I will send you through emails. Yeah, of course. Yeah. Mm-hmm. Just continue about. I'm sorry. Here. Some basics. It's very like. It's easy. For example, you define, as I said. Definition of addition is simply A plus B, and it's element wise. That means element by element they are add up. For example, if you're 4 by 4 and 5 by 5 data sets, the first, for example, the first element of first array will be added to the first element of the second array. It's called element wise. Subtraction is also element-wise. Multiplication is also element-wise. But there is like a tricky point, which is multiplication of 2D arrays, that you use the syntax of at sign, just to multiply 2D arrays, but it's again element wise. These are just some basics about the basic. Could you provide us more about our schedule and how we receive our materials? Do we have a Google Classroom? We have one session per week. Software engineering. We already decided about the contents of this course. I would focus on data analysis and processing. And I guess Bierman will give you some talks about. I'm sorry, I already forgot what we want to focus, but I would doubt if it's software engineering. I'm sorry, I'm not having some contents for the case of software engineering, but if, for example, you need it, maybe you can request to Javid, and then we ask people at OIST who are more familiar with this content, then they can provide some courses for you. It is good. It's always good to let us know what you really need in this aspect.
Thank you, Zohra. Let's book class, and for the question, we will have time at the end of the class.
Yes.
With Feroza, we will discuss how we can use like Python or other language for software engineering. There is no any tension. We will update you soon. Just let's focus on the class right now. Thank you.
No worries. Okay. Another important way of understanding your array is indexing. For example, if you just imagine you have this A and 10, 20, 30, 3 by 3, but you want to have access to the element of first row, but the second column, which means this number 20. The way you should write down it's A on a square bracket 0, 1, because numbering starts from 0 in Python. So first row means first row means this 0, and 0, means the first line, and 1 as the column means the second column. And for example, let me just clear output here. And for example, if you want to have access to third row and third column, you put a square bracket 2, 2. And as you can see, I ask it to, this is the third row, third column, which is indexed as 2, 2, and this one 0, 1, which is indexed as 20. Another concept that when you deal with, for example, big size of data is slicing. That means you just need one slice of this data, not the whole data in a row or in a column. So again, you use, for example, square bracket, and then in, for example, row section, you define a certain interval or like a span. And same for your, for example, columns. What does this mean? From 0 to 2. It means from row 0 and row 1, and columns means 1, but there is nothing after double dot, means 1 and after, all after 1. So these are all available in my code. And for example, again, if you, for example, want to have access to all rows, but only the first column, I'm sorry, it's the third. you use this one. It's called as like splicing. Sorry, slicing. I'm sorry. Okay. There is one more option which is not really useful, but it's good to know, which is navigating. Instead of putting positive integers, you put negative integers. -1 refers to the last element in your, for example, row or column, and -2, for example, it's the what's the word, 1 before the last, and so on and so forth, you know. But it starts from -1. -1 means the last, for example, if you put it in the first part section, it means the last row, and I'm sorry, and -2 means the one before last column. These are just like I title them in such a way, at least you get to know how to search. For example, these are the keywords that you can use to extend your practice. And also reshaping. For example, you have like a 2x2 or 3x3 2D arrays, but you want to get a 1D array, for example, or you want to make it, for example, if it's 2x4, you want to make it 4x2. You use the command reshaping. For example, here I have a 1D array, 1, 2, 3, 4, 5, 6. But I ask it to reshape it to 2x3. That means 2 rows, but 3 columns. So as you can see, I have already run. For example, the original B is 1, 2, 3, 4, 5, 6. But the reshaped B is 1, 2, 3, first row, 4, 5, 6, second row. So it's just a way to deal with, like, for example, if you make 1D to 2D, or if you have one 2D array, but you want to rearrange or reshape it from, for example, 3x2 to 2x3, I don't know, or 1x6, for example. These are just like basics that you need to know how to when you want to deal with big data sets. Another one is flattening. Flattening is actually used just to change all possible, for example, sort of 2D arrays to 1D. What does this do? For example, if you have, for example, 3 columns, 3 rows, I'm sorry, and you use it as like a flatten, it put all rows all together in series and returns you back a 1D array of data. For example, if I, for example, A is defined a bit higher. Sorry, I haven't brought it here. I guess this is A. And 23, next row 40, 50, 60, next row 70, 80, 90. But when I use flattening, it put all the rows in a series together and makes it 10, 23, 40, 50, 60, 70, 80. I mean, you can see it makes a 1D array for you. I'm sorry, let me, for now, delete this one. Yes, because we are not going to check it. One of the other actually functions, and that I really liked when I deal with big data, is Boolean indexing or NP-var actually, var function, as you can see. Boolean means you define a condition for your data set and then decide on your data based on that condition. The way that you use Boolean indexing is, for example, I have already written it here. You define a condition, you set a value, you set this value if it satisfies that condition, or you allocate this when your data is not satisfying this condition. And NP-var, I found it a bit hard to explain, so I prepared as an example. But I guess when you deal with big data sets, these two are really actually useful. It's good to get used to use this Boolean indexing and var function. For example, just imagine we have a 6x6 matrix of random integers which are between 1 and 100. We want to replace all even numbers with -1. For example, we have created a random data set. After generating this random data set, we want to replace all even numbers that are being created with the value of -1. And extract the submatrix of element greater than, for example, 50, keeping their original position. I mean, let's just solve this example one by one. First of all, we create our random data set. For example, I have written this, which makes like a matrix of 6x6. You can see I put the dimension here, but I want to have my random numbers from 1 to 100. And this gives you a random number generation of matrix 6x6. But beforehand, if you have noticed, I have used this command, which is mprandom.seed0. That means different random numbers are created at each time you run this code. Because just to randomize your random data set, because if whenever you run this code, it renews your matrix. I mean, we want to ensure that our random numbers get refreshed at each time of actually running this code. Okay, now we want to satisfy the first condition, which is replacing all even numbers with value -1. For example, for this one, first of all, we make a copy out of our generated file. So I feel like it's the best way to explaining this, just bringing it up with an example. First of all, using, for example, I put my my array name as math. I use math.copy_parentheses. I create a copy of my matrix that I created or generated in previous line. Here is the Boolean indexing that I was trying to teach you in this part. I said, okay, you please copy the original and store it math even replaced. I mean, this is the second created. Putting this, it says if each element of this array gets divided by 2 because this is the command that you define division by 2, but the result, I mean I'm sorry, I forgot the word in I guess it's called modulus operator. I mean, what is left, if what is left is 0, that means it's an even number, then you put that array as -1. Okay, which Boolean indexing we have been using here? Double equal. That, I define this condition in such a way. Let me just explain it again. Here, if each indices of each element of the data set gets divided by 2, and the result of the I'm sorry, I don't remember the word in English. باقی مانده, if you know in Persian, is 0. That means it's an even number. This double equal is actually our Boolean indexing. Make this element equal to -1, because we were asked to do this, you see? Okay, then we came up with this Boolean indexing condition. And then I asked it to, after doing this in a, this line will consider this condition for each element and replace it in case if they are even with -1. And then I asked it, okay, to now show me the latest version of no even numbers. I mean, which is replaced. Okay, here as the second things that we were asked to solve in this. Extract the submatrix of elements which are greater than 50. For example, we have created a 6x6 matrix. We already replaced even numbers with -1. Now we want to make a submatrix with only elements that are greater than 50. So how we want to do this? And of course, we again need to go through the elements one by one and come up with a Boolean indexing. But this time we say if the this element is bigger than 50, keep the math, this is as I explained you, this is the way. It's the condition. In this case, if the math is bigger than 50. If it happens, it keeps it. That means math is replaced with math. That means that element will be replaced with itself. So that means it's not changing. Okay. But if it doesn't satisfy this criteria, that means if it's lower than 50, then replace it with 0. This is the second way of defining your Boolean indexing. For example, in the first, we just simply said, I didn't use this actually value if true, value if false. I said, whenever it's even, make it equal to -1. I mean, replace it with -1. But here I have extra actually demand from the Python code. I said, okay, if it's greater than 50, keep it. If it's lower than 50, replace it with 0. I just wanted to show you with this example that Boolean indexing is very important in data analysis, and there is no unique way of using Boolean indexing. For example, in the first line, you see this way of using it, as long as it satisfies this condition, make this one. But here I said, if it satisfies, keep it. But if it doesn't satisfy, you should perform another act, which is replacing it with 0. So I have already in the title of this part yes, I'm sorry. I forgot to tell you that I have already merged my Boolean indexing with NP-where. Where is the condition that satisfies this? I'm sorry, my explanation was a bit not very accurate. This actually way of writing is mainly for where. I mean, with the combination of Boolean indexing. For example, this is our Boolean indexing, and it says whenever math is, for example, wherever you go, if the math is bigger than 50, keep math, otherwise make it 0. It's actually it's MP where with combination of Boolean indexing, which is 50. I'm sorry, I'm sorry, can you hear me now? I've got muted. So it's the combination of Boolean indexing, I'm sorry, with where function, which really helps you to have access to each elements of your matrix one by one, have a look into that element, and then decide what you want to do with this element. For example, if it satisfies this condition for this, in this example, you keep that element. If it doesn't satisfy, you replace it with value 0. So this is also like a way of dealing with data. I personally use this one, so it came up to my mind to like, it's good to use it. It was just like an extra practice. I just wanted to, for example, normalize each row. I mean, it's just, you know, just an example, maybe useful for you to see, for example, how you can see your data set, how you can have access, and how you can make a condition out of each element with Boolean indexing that creates a conditional situation in your coding. This is also just, I mean, just out of curiosity, if you're curious, I just wanted to normalize my data, but it's not really related to Boolean indexing and NP-where. The other actually important comment that I guess is very useful in data processing. This is my last explanation. I guess I'm done with explanation today because I feel like let's keep everything pretty simple. And as I said, please give me feedbacks after this course, and I can decide how difficult the next session should be, or if it's already good or it's acceptable. Sorry, I know, as I told you, I would like to explain again that it's really my first time trying to teach Python, so I am really happy if you provide me with some feedbacks. The other actually function that I want to talk about is broadcasting. You know, it's actually a very powerful approach to in which that a smaller arrays, if you want to deal with, for example, two sets of arrays, and they are not equal in size. for example, one is 2 by 2, the other one is 3 by 3. So because your data are not necessarily having same shapes, but you want to find a way to actually interact these two data set together, because they are not necessarily in the same size and same shape. For example, this is, when the smaller array automatically expands its shape to match another larger array. So as if it makes itself, the smaller array makes itself compatible with the larger array, just to make them intractable. It's very a powerful tool to, for example, deal with arrays which have different shapes. I would recommend, for example, go through the details on your own, because as I told you, I give you these just like some keywords that it's good how to start at least to deal with different how to deal with analyzing or processing data. For example, as I said, the smaller array automatically expands its shape to match with the larger array, and then you can do some operations like addition, subtraction, multiplication, and etc. But again, it's like an element-wise approach. Element by element, they get in touch and starts, for example, doing some basic, for example, or whatever analysis you want to do. And I also provide you with another example for broadcasting. For example, here I said you have a data set of grades for 4 students for 5 subjects. And for example, I ask you to calculate how many subjects each student failed. For example, if the grade is less than 70, we consider it as failing. And for example, you pick a subject and you see, for example, for how many subjects, for example, you pick a student and you see for how many subjects this student has failed. And for example, you come up with the condition of grade less than 70. It's good because it's still includes Boolean indexing, the part that I explained you on top. And then I ask you to calculate the differences of each grade from the average grade of that subject, for example, and then create a curve that adds points to all failing grades, so that after adding failing and grade, it become equal to 70. If you don't mind, I would like you to go through this example on your own, because I wanted to assign you an assignment, but I felt like maybe it's a bit too early for us to deal with assignments. So instead, I came up with this idea just to put an example here. The answer is also here, so you can cheat a little. But at least it's a good way to get some clue how to deal with this experiment. This example. I would like to start my next session and asks one of you to explain this example for us. So I feel like maybe it's easier to assign you a task, but at least it's a way of starting our interaction with each other. You go through this example, you even read the answer, and then one of you please explain to me or others how we deal with broadcasting. I mean, it's a very useful approach. It's good to get to know how to code this situation. So there is no assignment for him this session, but it's just an example. But I would like to ask one of you, please, to explain to the other how to deal with this example. For this session, I am done, and I guess I have explained all of my contents, and I'm happy to answer some possible questions. I will present 3 sessions for you, and German will present 3 more sessions. But this time, I don't have any assignment, but we will be having assignments for next sessions. As I said, I would like to ask one of you to go through the example of broadcasting and explain it to all of us. But the answer is already there, so it's pretty easy to understand. But at least I feel like it's an easy way of starting our mutual actually interaction. I guess there is a question.
Yeah, May, my question is related to the session. So do we have tomorrow like session?
Oh, no. It's next Sunday.
Okay, thank you.
No worries. Next Sunday, same time. Please let me know, for example, if you have some like favorite part of data analysis and processing, then I have 1 week to provide some contents for this. Otherwise, I will follow the contents that I have already decided on. But if it will be more useful if you already have some preferences, and it will be great if you let me know. Any question?
Thank you so much, Zohra. Thank you for the nice and great presentation that you had. Right now, if there is any question from the students, please, you can have your question. Else, for today, the class is done.
Yes.
So we will see next week, the same day and the same time.
Yes. But sorry, David, I have a question. Will I have access to the email addresses of attendees to share the link?
For sure, I will update you, and I will send you all the email contents of the students. No worries.
Thank you so much, and I'm so happy to get some feedback.
Thank you. In the chat box, Greeting just wanted to ask how long will... Okay. Regarding the course, Mr. 𝗂𝗏𝗵𝗁𝗂𝗏, as Ms. Zohra discussed already, we will have 3 sessions by Zohra and 3 other sessions by Jeremy.
Yes.
Next week's at all.
Yes.
Okay. Thank you very much, Zohra. Thank you.
Yes.
And see you all next week. Due to Ashura, I think in Afghanistan, many of our students were busy with the program, so I think they couldn't join. For the week, maybe we have some other students from Afghanistan, so we have some international students as well. That's why we have to have the classes in English. Else, for Zohra, it's also okay that she can speak in Farsi,
Yes.
so there's no any problem.
If I'm really hard to understand, I can say some sentences in Persian. In Farsi.
Roman Wali also said that today there is no network connection in Afghanistan. This is another problem. No worries, we already recorded the session and we will upload it. So I will send a link with a student. I hope there is no problem with Zohra because we already recorded the video. Zahra, yeah, we will upload it on YouTube and we will share the link with you.
Yes, that's perfect. Thanks. Thanks.
Okay. Thank you so much. Have a nice day.
Yes, have a nice day. It was nice to be here.
Bye.
Bye. Bye.